Hi everybody. In this video, we are going to see how to configure Blackhole Attack in Contiki Kuja. Now, I already installed Contiki Kuja. I'm having a VMware workstation, so it's already configured here. I'm using Instant Contiki 3.0. So let me start VMware. Now, you can see already the Instant Contiki I already loaded here. So I'm just going to load it again. So play with virtual machine. So Contiki is loading now. The default username is user. I'm going to give the username as user. So now we are inside Kontiki. Now the next step is I want to run the simulator. So the simulator is the Kuja simulator. So I'm going to the terminal. So in the terminal, cd Kontiki. Then you can go to the folder tools. So in the tools only, okay, we are having Kuja. So I'm going to the folder cd Kuja. Now the command is and run. Okay, so there's a command to start. Okay, the Kuja simulator. So we are in the Kuja simulator now. First thing, I'm going to show you a reference topology. So reference topology means the topology which is not having any attacker. Okay, so I'm going to load the reference topology and we are going to see that. Then we are going to have a single black hole attacker and we are going to see how it is affecting the network. Now let me go to the file. I'm just already created the simulator, the simulation. So I'm going to open it. Okay, so you can see here without attacker. So I already created the simulator, the simulation. It is without attacker. I'm just going to open it. Now, so these are the nodes I'm going to have here. Okay, you can see the uh, wireless sensor nodes, or you can say it is IoT devices. So here, number one, so the one is going to be the sync node. Okay, so this is called the sync node. So sync node is going to communicate with the internet. It will be connected with the internet. So all the other nodes, they are called UDP senders. Okay, so this is going to be the UDP sync, and these are all the UDP sender. So UDP senders, they are going to communicate with the UDP sync. So here all the nodes are the legitimate nodes. Okay, so there is no attacker here. Okay, so they are going to communicate with the sync. So before that, you can go to the view and you can select some options. What are the options to be displayed? Okay, in the simulation, you can do it. So for example, mode ID. So if I just unselect it, automatically the mode ID, okay, the ID numbers are displayed. If you want the ID, you can just select it, mode ID. Then the next one is the address, IP or RIME. So this is going to display the IP address. So generally here IPv6 address will be used. So if you want to display the IP address, you can enable it. So if you don't want, you can just leave it. So this is going to be the IP address option. So the next one is the printf. So whatever the node is going to print. In some cases, the node will print some data. Okay. In some cases, it may not print. So if you are using any print statement inside, automatically it is going to print, and you can see the print here. Okay. So if you want to enable this, you can do it. Then LEDs. So there will be three different types of LEDs will be available. So you can enable the LEDs. Okay. So these are all not necessary. You can try. You can try it later. Then the very important thing is the radio traffic. So what is the radio traffic means? The packet, okay, the nodes are going to exchange. Okay, we can say is the data. The data it is going to transmit. Okay, that is going to be the radio traffic. Then position. So position means that means the location x comma y. Okay, so x-axis and y-axis where exactly this node is okay available. You can move the nodes. Okay, there is no problem. You can move anywhere. Okay, so this is going to display the location of every node. Okay, including the sync node. So I'm just going to disable it. Okay, position I'm going to disable it. Then the next one is 100-meter background grid. So this is the grid. Okay, so if you want to disable it, you can disable the grid. If you want to enable it, you can have it. Then the next one is going to be the mode type. So what type of mode? So here we are using two different types of modes. One is the UDP sender and another one is the UDP sync. So if you unselect it, okay, everything will be the same. Okay, there is no difference here. So if you want to make the difference means you can go for mode type. So it will display the type of the mode. Then the next option is going to be the mode attributes. So you can select the mode attributes. That means some values about the mode. Okay, so by default this will be disabled. I'm just removing it. Then the next one is going to be the radio environment. Radio environment means if you click any node, you can see the coverage area. Okay, so this is going to be the radio range. Okay, the radio range of node 1. You can click any node. So now I'm going for node 2. So if I click node 2, you can see this is going to be the radio range. So you can enable the radio environment. Then the another option is called the code. So code is going to be the program. Here I'm not going to write any code, so I'm not going to select this. So now this is the basic thing here that you have to keep it in your mind. Now, so what we are going to do means here, if you just select one, that means the sync node. Okay, you can see 9, 12, 11, 5, and 8. So these are the nodes which are available within the radio range of 1. Okay, within the radio range of 1. So that means 8 can directly communicate with 1, 5 can directly communicate with 1, 9, node 9 can directly communicate with 1, node 12 directly communicate with 1, and then node 11 can directly communicate with 1. So this is well and good. But if you see the nodes which are outside, okay, that means 4, 2, 15, 7, 6, 10, 13. So all these things, how they can communicate means they can communicate with the sync node only through other nodes. Okay, for example, so 4 is going to communicate with the 15, then 15 is going to communicate with the 8, and 8 is going to communicate with 1. Okay, so this is how the communication is going to take place. The same thing. If you take node number 2 is going to communicate with 15, node number 2 is going to communicate with the 8, and the 8 is going to communicate with 1. So this is the way it is going to work. So what I'm trying to say here means if a node is not able to communicate directly with the sync node, so the node is going to communicate through some other nodes. Okay, so this is the concept. Now, the next stage, what I'm going to do means I'm going to run this topology and we are going to see the result. In the next one, that means in the second scenario, what I'm going to do means I'm going to make this 15. So node number 15 is a legitimate now. So now what I'm going to do means I'm going to make this 15 as a black hole attacker. So what does it black hole? What does it mean? Okay, the black hole attacker means so a black hole attacker means whatever the packets it is receiving, it is going to drop the packets. Okay, for example, if 2 wants to communicate to 1 means, so 2 is going to communicate via 15. So all the packets will come to 15. Same thing, the 4. From 4, all the packets will go to 15, then okay to 8. So what 15 is going to do means, the 15 is going to become a black hole attacker. So in that case, okay, whatever the packet sent from 2 and 4, automatically the black hole is going to drop. And in one stage, in a particular stage, what is going to happen means both 4 and 8, they are going to be removed from the network. Okay, they cannot communicate with the network. So they will be completely discarded. Okay, they cannot communicate with other nodes in the network. So this is going to be the result of black hole attack. Now, so this is a reference, the reference topology. So here we don't have any attacker, a normal network, and we are going to execute. So now, so what I'm going to do means I'm going for the tools. So in the tools, you can see I want to see the data. Okay, I want to collect some data about this topology. So I'm going for collect view. So collect view means some statistical data you can collect. Okay, so I'm going for the collect view and I'm going for sky 1. So sky 1 it is our sync node. So for the sync node, I'm collecting the data. Now, so here you can start the simulator now. Okay, the simulator is not, it's not, still it is not running. So what you can do means you can click start here. So it started the devices, that means they are started communicating with each other. Now you can go to, okay, this is the collect view. In the collect view, you can do start collect. Then you can click on send commands to nodes. Okay, you can click on this and you have to wait for few seconds. Okay, not seconds, in minutes. So if you wait for a few minutes, you can see, okay, the data is started collecting. Now you can just select all. Okay, you click on the all and you can see the different statistical data about this network. Okay, so what does that means? I'm just going to the sensor map. So in the sensor map, or you can go to the network map, okay, network graph, you can see one is going to be the sink. Okay, one is the sink, and everybody is communicating with the sink. Okay, they are going to communicate with the sink. So sink is going to be the root here. Okay, it is going to be the root. Now you can see here 215. Okay, you can just follow it. Okay, where is 2? Okay, you can follow it. So if you find 2, okay, the 2 is available here. You can just maximize it. Now you can see. So 2. So 2 is communicating via 15. So then it is communicating via 4. Okay, you can see the different path how they are communicating. Okay, so 2 is communicating with the 15, then 15 is communicating with some other, okay, node, and finally they are going to communicate with 1. The same thing, you can see the another one, 13, 13 is communicating with 12, and 12 is communicating with 1. So finally, okay, every node they are going to communicate with the sync node. Okay, that is going to be the concept here. So now data, okay, that means your simulator is running now. We are going to see some statistical data. Okay, what is the statistical data means? You can go for one by one here. You can go to the sensors here. Okay, just click the sensors. You can see this is going to be the average temperature. So the temperature of each and every device. Okay, so you are having the nodes 11, 9, 13, 7, 8, 12, 15, 10, 6, 7. For all the nodes, okay, we are getting the temperature. What is the average temperature? So the temperature is given here. The same thing, okay, you can just go for the temperature, then battery voltage. So battery voltage you already know because these are all the devices which is running with the on the battery. Okay, this is called LLN. Okay, that means low power and noisy networks. So in this network, all the devices they are going to run only on the battery. That means power consumption is going to be a major factor here. Then the next one you can see the go to the network. So in the network you can see plenty of parameters available here. So there will be lot of okay data you can collect it here from this particular graphs. Then the next very important is a very important thing is the power. Okay, power is going to be very important. Okay, now you can see. So the power consumption detail of every node. So node number 11, node number 9, node number 13. Okay, so you can use this as a graph in your reports also. If you're writing a report means you can use this. So these are all the power consumption detail. But if you see the node 15, so 15 power consumption is more comparing with the others. Okay, so why? Because 4 is communicating with the 15 and 2 is communicating with the 15. So the power consumption of 15, the node number 15 is higher than the others. Okay, so you can have a comparison like that. Then the next one is going to be the node info. Okay, what is that node info means? So this is a complete statistical data about your topology. That means every node, okay, they are going to take node 1, node 2, node 4, okay, node 5, 6, 7, 8, okay, for all the nodes they are taking, okay. Now you can see how many packets received, how many packets, duplicate packets, how many packets lost, there is no loss here, okay, then how many hops, how many hops means jumps, so how many jumps, okay, they are making to reach the sink, okay, to reach the sink node. Okay, now you see if you take node number 2 to reach the sink node, so from 2 to 15 this is going to be number 1 first hop, from 15 to 8 second hop, then 8 to 1, okay, this is the third hop. So 3 jumps 2 will make to reach 1. Okay, you can see for node number 2 the number of hops is 3. The same thing if you go for 4, okay, that means the node number 4, if you go for node number 4 also, okay, 3 jumps, okay, 3 hops it must take to reach the sink. But if you take 9, Okay, node number 9. So what is node number 9 means? It is very near to 1. Okay, that means only one hop is enough. So now you can see node number 9, only one hop, okay, it is going to reach the sync. So this is the number of hops, then routing metrics, ETX value. Okay, so there are plenty of data you can see. Okay, how many, what is the power consumption details, CPU power, LPM power. Okay, so listening power, transmit power, all the data you can get it from here. So this is a normal network. Okay, we can say this is a reference topology. Okay, you can see the IP address here, FE80. This is the IPv6 address. So if you don't want IP address, you can remove the IP address. Okay, so they are now communicating with each other. So this is a normal network. Okay, a normal network. So in this, there is no attacker. Now, in the same topology, I'm going to introduce a black hole attacker. Okay, I'm going to introduce. So now, I'm just going to pause this simulator. So let me open the new simulator. I'm just going to open. Okay, so single black hole attacker. Now, the same topology. So what I did means we are converting, okay, the node number 15 here, it was there. So we removed that node and we are going to make this as a black hole attacker. So now you can see there will be three different colors. So one is going to be your sync node, all the others, okay, it is going to be the UDP sender, and this node is the black hole attacker. So now, what the black hole attacker is going to do here in this case means whatever the packet sent from 2 and 4, okay, 2 and 4, so the black hole attacker is going to drop the packets. Okay, it is not going to transmit it. And also, it won't packet, okay, that means the packet from this black hole attacker also, it will be completely dropped. So, this is the concept. At one particular stage, if you run the simulator for 2-3 minutes, so automatically node number 2 and 4 will be removed from your topology. Okay, they will not be connected. So they will not be able to communicate with others. Okay, so this is going to be the black hole concept. So now we are going to run the simulator. I'm just going to start the simulator. So before that, you can go for the tools. You can go for the collect view, sky mode. Okay, so you can see all the nodes are available here. You can give start collect. Then you can click on the send commands to nodes. Then you can click here start. So now the simulator is start. So you have to wait for few minutes. Okay, then only you will get the proper output. So now the collect view is going on. Okay, so collect view is going on. So now you can go for one by one and you can see what is happening. But wait, okay, we will see it after few minutes. Okay, let the topology run for some time. Okay, then only you can collect the statistics, proper statistics you can collect. It's already collecting the data, so there is no issue. I'm just going to show you. Okay, so now you can see here I'm going for sensor map, or you can go to the network map. Okay, so now you can see your topology, how the topology is working. Now if you closely observe, you will understand. See, 2 is now completely, it is discarded, it is detached from your network. Okay, number 2 and number 4. So these two nodes, they are not able to communicate with others. Okay, they're not able to communicate with others. Okay, because it is completely dropped. Okay, that means the packet sent by, okay, this 2 and 4, it is completely dropped by the black hole attacker. So the black hole attacker, okay, it is what to say, it's a detached, it is removed 2 and 4 from the network. So 2 and 4, they are not able to communicate with the other devices now. So this is the first one. Okay, you can see the effect like this. Then the one more thing is you can go for the, okay, node info. Okay, I'm just going for the node info. So in the node info, you can see the numbers. Okay, first you must note the ID. Okay, that means node ID, the node ID 2 and 4. Now you can see here 2 and 4. Okay, so you see the number of packets received. number of packets received is 0. Then you can go for 4. So number of packets received is 0. But the remaining nodes you can see at least it is having some packets. Okay, it is having some packets. Now you can see 15. So 15, okay, it is going to be completely 0. So what we understand from this means, so the black hole attacker, okay, black hole attacker is receiving the packets from the other nodes, but it is not going to forward it. Okay, it is not going to forward it. So all the packets are dropped by this, okay, black hole attacker. Now, so you can go for further information, okay, so like uh, the power consumption details, okay, anything if you go. Now, I'm just going for the power consumption details here. So now you can see here 8, 5, 14, okay, 11, 10, 9, 12, 13, 17, 16 is there. You cannot find 214. Okay, 214 you cannot find. So because it is completely detached, it is completely discarded, or you can say it is completely cut off from your network. So this is the effect of black hole, okay, concept.